In grade 12 math, we take trigonometry and apply it to something called the unit circle. So now trigonometry is going to be connected to circles. A unit circle is a circle at 0, 0 with a radius of 1. So unit circle, center at the origin, radius of 1. And with this, we have some major discoveries in trigonometry. In fact, from this circle, we are going to get 3 big ideas that we're going to use throughout this unit. So, big idea number 1. Well, if you would pick any point on this unit circle, and you go back to the nearest x-axis, you can make a right-angled triangle. And that right-angled triangle involves your reference angle. And if we looked at the angle, or our reference angle right here, you could figure out what sine, cos, and tangent are. Now, any point on your unit circle will have an x-coordinate and a y-coordinate. But now when I look at sine of that angle, it's opposite over hypotenuse. My opposite side is y. My hypotenuse, because it's a unit circle with a radius of 1, is 1. And y over 1 is just y. And if I do cos, well, that would be adjacent over hypotenuse, which is x over 1, which is just x. And if I would do tan, I get tan of theta is opposite over adjacent would be y over x. Now you have some space on the bottom of page 470. So on the bottom of page 470, you can write 3 big ideas. And we have in fact already done 2 of them. Big idea number 1, that just comes from us labeling this point. Big idea number 1. Points on the unit circle, which is x comma y, can be written as, well, x is equal to cos of theta, and y is equal to sine of theta. So from that triangle, we solved for sine of theta, we found out it's equal to y. That means we can replace y's with sine of theta. We can replace x's with cos of theta. Any point on the unit circle, the x-coordinate is equal to cos of theta, the y-coordinate is equal to sine of theta. And if x is cos of theta and y is sine of theta, that actually gives us big idea number 2. What's another way I could write tan of theta? Well, if y is sine and x is cos, we get the following relationship. Big idea number 2 is that tan of theta is always sine of theta over cos of theta. I'm going to prove it to you. Well, this won't prove it, but it should convince you that it's most likely true, or else I'm a magician. Okay? Pull up my calculator here. What I'm going to get you to do is, in order to make this magician appear to be even more fascinating, pick a number between 1 and 1,000,000.
$456,827.
Negative 0.23086819911. And now, pick up my fraction button. On the top, I'm going to write sine 456,827. On the bottom, I'm going to write cos 456,827. They are exactly the same. Either I'm a magician, or this is actually a big idea. This will work. Now, technically, we only proved that it works for 456,827 degrees. But the fact that I was confident in you picking any number between 1 and a million, right? Kind of, then I'm either the magician part right, or it does work for anything. You can try it with other numbers. No matter what number you put in there for the angle, comes out the same every single time. And that's based on this picture that we drew, right? Because tan is y over x, and on the unit circles, sine of theta is y and cos of theta is x. I can replace the y with sine of theta, the x with cos of theta, and I get the big idea. There is a very important formula that you learned with sides and a triangle. Do you remember what it is? You've used it a ton. Probably one of the formulas you've used the most with triangles. If you know two sides and you want to find the third side, what would you do if it's a right angle triangle? Pythagorean theorem, which is a squared plus b squared equals c squared. If I do Pythagorean theorem with this triangle, I would get x squared plus y squared equals 1. That technically, look at this. That's technically the equation of a circle. It's just Pythagorean theorem. Sorry to disappoint. A squared plus b squared equals c squared is just how they figure out formulas for circles. I know it's super disappointing. You'd like formula for circles to be something fascinating and huge. No, it's just a squared plus b squared equals c squared, where the c squared is your radius. So here, if I'm starting at 0, 0, I would just have this length is x, this length is y, my radius is 1, x squared plus y squared equals 1 squared. But that then gives us big idea number 3. Right? If the equation of the circle is x squared plus y squared equals 1, and x is cos of theta, then cos squared of theta, and when we square sine and cos, we put the squared in the middle, not at the end. Because if we put it at the end, you have this question, is just the theta squared or is the whole thing squared? So you could clarify the whole thing by adding brackets, but that would be so much work to add brackets. So mathematician says, how can we be creative to make it less work for ourselves? Let's confuse students and put the squared here. Excellent. So cos squared theta plus sine squared theta is always equal to 1. Let's double check this. Let's take out the calculator again. The calculator doesn't let me, I have to put it in brackets. Well, let's use the same number, 456,827. Or maybe that's, no, let's change it up because you might think that 456,827 is just magical. And you want to pick another random number between 1 and a million?
56285.
56285. So I put that whole thing in brackets and I squared. Okay? If you're working along at home, quickly do the mental math. Remember 15 decimal places. Okay? And now we're going to do sine, put it in brackets, sine of 56285, close those brackets up and square it. Also, do the mental math. Figure that out in your head. Remember 15 decimal places. Then take those 15 decimal places, add those 15 decimal places together, and we get 1 every single time. Sine squared theta plus cos squared theta is equal to 1 if the thetas are the same. You can't make one 56285 and the other one 56284. No, will not work. They have to be identical, but if they're identical, that is our big idea number 3. Lots of the questions that we do in this unit use these 3 big ideas in some way or another. So they will become very important. If you get stuck on a question, you'll often say to yourself, I wonder if I could use a big idea to help me with this. Okay, and if you turn to page 470, which you might be on because you're writing these things at the bottom, we are going to learn in grade 12 3 new trig functions. You already know sine, cosine, and tangent. You will add to it the secant ratio, the cosecant ratio, and the cotangent ratio. And these are reciprocal ones. So secant of theta is 1 over cos of theta. Cosecant of theta is 1 over sine of theta. I know what you're thinking. Why couldn't they make the s's go with s's and c's go with c's? Just to confuse me? I don't think you'll have a problem, though. Somehow you're going to remember that cotangent of theta goes with tangent. I don't know how you'll remember that one, but something will help you remember that cotangent goes with tangent. But you're going to have to remember cosecant goes with sine, and secant goes with cos. Opposite letters. Those will be definitions you have to remember. And these are our reciprocal trig functions. So with those big ideas and our reciprocal functions, we are ready for example number 2. And we're actually going to skip 2A right now. We're going to do a project where you have to memorize a lot of trig values in degrees and radians. You might remember your special triangles that you had to memorize in grade 11. We have to do those all again, but we also add radian measures for it. So we're going to skip 2A and just do 2B right now. Determine the approximate values for the 6 trig ratios of 586 degrees. So we're going to figure out sine of 586 degrees, cos of 586 degrees, tan of 586 degrees. We're going to get all of those from our calculators. We're also going to get the reciprocal ones. So we're going to get reciprocal, so cosecant of 586 degrees, secant of 586 degrees, and cotangent of 586 degrees. And these are mostly easy because if you have a calculator, you'll take out your calculator and you'll just do sine of 586 and push enter. Negative 0.719. Okay, so one thing that I do for practice here is I start by writing 3 decimal places. Then I reread my question just to make sure they didn't say something else. If nothing said, I need 3 decimal places. This one says nearest thousandth. How many decimal places is your nearest thousandth? 3 decimal places. I don't know who decided that putting a TH on the end of words was a good idea. But there we have thousandths, hundredths. It's like the hardest thing to do smoothly without looking awkward. So cos of 586, same thing. We go to our calculator. We type in cos 586, push enter. We type in tan of 586 and push enter. So we got negative 0.695. I'm not going to remember both of them. And the other one was 1.036. But unfortunately, we do not have a cosecant button. We do not have a secant button, and we do not have a cotangent button. So we need to, when we go to type these into our calculator, if you have a newer calculator, graphing calculator, and you can go alpha y equals and get this fraction button, super nice. If not, you can still use the dividing button. But I'm going to go write 1 divided by sine of 586, and this will be cosecant. I will do 1 divided by cos of 586, and this will be secant. And I will do 1 divided by tan of 586. Whoa, I screwed up. There we go. And I will get cotangent. Negative 1 point, oh, I'm going to cheat. I'm going to write these in. So 1 over sine, negative 1.390. That is going to be my cosecant. 1 over cos, negative 1. Oh, this is another fun rounding one. To 3 decimal places, do you see that that 4th decimal place is a 5? So if you round it up, that would make this a 0, which would make that a 4. It's tricky rounding. 4, 4, 0. And the last one, 0.966. There we have all of the trig ratios to the nearest thousandth. Okay. You can use the cast rule to tell me what quadrant 586 degrees is in. Look at the answers. How would we use the cast rule to determine what quadrant 586 degrees is? What did you do?
It's the third one.
It's the third one. How did you know? How did you use the cast rule?
10 is the only positive one.
10 is the only positive one. So according to our cast rule, it has to be in quadrant 3. Can you tell me what the first angle? If I was going the first time around and I ended in quadrant 3 and I was coterminal with 586, what angle would that be? $226. How did you figure that out?
Take 586.
Took 586, which was more than one time around, and you minus 360 to go backwards to see where you ended up. If that didn't give you the first time around, you could just subtract 360 again. And you could keep subtracting 360 until you got some answer between 0 and 360. Okay? So often they'll say, hey, can you tell me something that's coterminal with 586? And it's multiple choice, and they have a bunch of options there. So you could keep adding or subtracting 360 degrees to find that out. Sometimes people add or subtract 360 degrees and go, oh, 226. I know that's in quadrant 3 as well, without using my cast rule. So we have multiple options for figuring some of these things out. The only question I'm going to get you to circle right now is 7B.